So this video is about radians. And so right here, what is the measure of the angle in radians? We've been dealing with degrees and now it's radians. So we have an arc length here of 10 and a radius of 5. This will give us, if we divide them, 2. So it's 2 radians. So what it is the number of radiuses, I don't think that's a word, but it would be radii that the arc length has made. So if you take this 10 and divide it by 5, that means that this arc length has spanned 2 radiuses. So it's 2 radian. So let's look at Desmos to see this. So you can see this is 1 radian. So we have 1 radius and our arc length is a distance of 1. So now if I do 2 radians, you can see my arc length now is a distance of 2 with a radius of 1. So it's twice the radiuses. And when I go to 3, it has done now 3 radiuses. So watch, if I make my radius larger, you can see the same thing happens. So if I go back to 1, my radius here is 2, and my arc length is 2. So 2 divided by 2 is 1. So this distance is exactly the same as that distance. And if I go to 2 radians, this distance right here that we have traveled is now twice that radius. If I were to take this radius and make it like a limp string and then trace it to here and do it again, it would be twice. So if I go to 3, it's the same thing. That's 4 radians. So you can see it's a distance of 8 with a radius of 2. It's 4 times that. So all radians represent is just the relationship between these two. If you take your arc length, divide it by the radius, it tells you how many radians you have spanned. So see, if I make it 3, then now we have 12. So 4 radians with a radius of 3 would be an arc length of 12. It's because 12 divided by 3 is 4. And again, if I go to 5 radians, you can see now that that's 15 with a radius of 3. That would be 5. So hopefully you get the idea. So how does that compare with our normal angles? So we already know this is 0. This is 180, and then it comes back around and does 360. So if you look at it, 180 degrees is from here to here. That's half a circle. So if you remember, circumference of a circle is 2 pi r. So if we did half the circumference, we would have half of 2 pi r, which is just pi r. So that little yellow part right there is pi r. That's our length. So our arc length would be pi r, and the radius would be r. So if they cancel, you get pi. So 180 degrees is pi. And then again, 360 is all the way around. So that would be 2 pi r divided by r, which is 2 pi. So 180 degrees is pi. 360 is 2 pi. And that's our relationship. So when we want to convert back and forth, we use these 1-to-1 ratios to convert. So we're going to be using this first one here. That is the important one because it's nicer. We don't want to have 2 pi. We'd rather just use pi because pi is better. I mean, 2 pi's would be better than 1 pi, but then again, you get sick. So back to this. So what we're going to do is take that degree symbol and replace it with pi over 180 radians. Where did I get that from? Well, if you take 180 degrees and we say that that is pi radians, then if I divide both sides by 180, I get 1 degree is equal to pi over 180. And that's our relationship. So we can take our degree symbol, our 1 degree, because this is 23 times 1 degree, and we would get pi over 180. So we take the degree symbol, replace it with pi over 180. And that gives us 23 pi over 180 radians. And that's it. That's how you convert them. So degrees is now radians. And we do the same idea. So if you think about 180 degrees equals pi radians, if I divide both sides by pi, I would get 1 radian is equal to 180 degrees over pi. So we can take the radian part and replace it with 180 over pi. But the way I look at it is I want to get rid of degrees, so I put degrees on the bottom. If I want to get rid of radians, I put radians on the bottom. So if you think about that little radian sitting there, all we're doing is canceling it, and now we're left with a degree symbol. We can also cancel the pi. So all we need to do is 3.25 times 180, and we get 585. So this is 585. Let's put that in blue. 585 degrees, which makes sense because remember 2 pi is all the way around. And so we've gone around once and then again. So we're past 360 degrees. All right, so let's try some. So we're going to convert 35 degrees. So again, we want to put degrees on the bottom and then pi radians on the top. And this would still work with using 2 pi and 360, but we're going to keep it the way it is. And then we take 35 and 180. So we go alpha y, that gives us our fraction, 35 over 180, and it'll simplify our fraction for us to 7 over 36. So this is 7 pi over 36. And you don't have to write radians if you don't want to. 7 pi over 36 is the radian. Degrees, you do have to put the degree symbol. All right, let's try it again. This is 25 degrees, and then we go pi over 180. See, the degree symbols are canceling. And then in your calculator, if you don't have the alpha y, you just do 25 divided by 180, hit enter, and you go math, and then number 1 is fraction, and hit enter. Otherwise, you're going to sit here and just keep canceling, and they just have a 5 in common. So 5 and 5, you would get 5 pi over 36. All right, so the same idea here. We're trying to get rid of radians. So think of a little radian sitting up there instead of the degree symbol. And now we put radians on the bottom. So that would be pi, and then degrees on the top. And so then we can cancel. The pi's also cancel. And so all we have now is 180 divided by 5, which is 36 degrees. And so that's it. We want to get rid of degrees, degrees on the bottom. You want to get rid of radians, radians on the bottom. What if there is no pi? Well, same thing. It's 7.12, right? And it's, again, you don't have to write radians, but that would be pi over 180. And so little radians are canceling. And so we end up with 7.12 times 180 over pi. And so we're just going to plug that into our calculator. So 7.12 times 180 divided by pi. And we get 407.9, when we do 95, 407.95 degrees. And there you have it. So that is radians to degrees, degrees to radians. Thank you.